In this example, we're going to be solving for the amount of time that it takes some object to reach a final velocity given an acceleration and an initial velocity. The problem reads a motorcycle accelerates from rest at a rate of 3.0 meters per second squared. How long does it take the motorcycle to reach a speed of 24 meters per second? Remember, an acceleration of 3.0 meters per second squared means that every second the velocity increases by 3.0 meters per second. So I begin by drawing a little diagram just so that I can visualize the motion. So there's my man on a motorcycle, and I've decided that he's moving to the right, and we'll call that positive. Initially, he is moving at a rate of 0 meters per second. How do I know this? I know this because if I look in the problem tells me he starts from rest. This is one of those key words that we need to make sure we remember. Our final velocity in this case is 24.0 meters per second. The acceleration is 3.0 meters per second squared. And again, what we're looking for is the amount of time it takes to reach this final velocity. Acceleration is just our change in velocity over our change in time. So our change in velocity is our final velocity minus our initial velocity. And again, we're just dividing by the amount of time that it takes to change our velocity. Rearranging so that we can solve for t. And then we will plug into our equation our values that we found earlier. So 24.0 meters per second minus 0 meters per second divided by 3.0 meters per second squared. And we find that it takes 8.0 seconds to increase our velocity from 0 meters per second to 24.0 meters per second. And this makes sense, right? Because every second that goes by, we are increasing our velocity by 3.0 meters per second. That means that after 1 second, we've increased by 3 meters per second. After 2 seconds, we've increased by 6. After 3 seconds, we've increased by 9 meters per second, and so on and so forth, until after 8 seconds, we've changed our velocity from 0 meters per second to 24 meters per second.